In this video, we're going to compare the pattern we constructed previously with the traditional method against the same pattern but constructed with the grid method. The aim is to see which of these methods comply with the proportional relationship. You can call it geometry in action. It will show how disciplined geometry works to compose these patterns. Let's check the three shapes we mentioned in the first video of this tutorial. Remember that this dart shape was the first indication that the pattern constructed by the grid method is deformed. As you can see now, both darts in the pattern constructed by the traditional method are identical. Now let's look at the second shape that looks like a spade. The shape from the left pattern fits exactly inside the star, which means it is symmetrical and it has the correct proportion in relation to the star. On the other hand, the deformation in the shape from the right pattern becomes more visible when we compare it with the star. The third shape that had a problem was the hexagon. In the left pattern, the hexagon now is a regular shape, and all sides of the hexagon are the same length, and all angles are equal. Also, the width of the hexagon is equal to the width of 3 points of the star. You can also notice the relationship between the hexagon and the petal shape. As you can see, none of these relationships exist in the hexagon from the right pattern. Now let's compare other shapes with the star. Starting with the petal shape, the petal from the pattern constructed with the traditional method fits exactly inside the star, and the same shape from the other pattern does not have any kind of relation with the star. If we compare the arrow shape, you can see that the one from the correct pattern fits between the center and the point of the star. And when the shape is rotated around the center of the star, it will repeat 3 full times. The number of repeats also correspond with the type of fold, i.e. the 6th fold. And if we compare this shape from the corner of the pattern, the shape from the correct pattern fits exactly inside the star, but the one from the pattern constructed with the grid method does not correspond with the star. Now let's compare the shapes with each other. When putting 2 darts inside the spade, we get an interesting composition. When we move this shape inside the star, it becomes clear that it fits between the center and the perimeter of the star. And by rotating this shape around the center of the star, it will complete full revolution when repeated 6 times. The number of repeats also correspond with the 6th fold. When we compare this shape with the hexagon, this shape will fit perfectly inside the hexagon. And notice we get none of these relationships from the pattern constructed by the grid method. Now when we compare the hexagon with the spade in this layout, a new shape appears. This shape, which looks like a drum, appears frequently in the 6th fold pattern. This drum also fits inside the star. Throughout all these comparisons, it is obvious that the shapes in the pattern constructed with the traditional method comply fully with the proportional relationship rules. On the other hand, 6 out of 7 shapes in the pattern constructed by the grid method fails to show any noticeable relationship with the star or with each other. These comparisons illustrate the importance of the rules mentioned previously in the first video of this tutorial. Without these rules, you can end up with something that looks like a geometric pattern, but it will have none of the visual and the artistic values of the real geometric patterns. And thank you for watching this video.